So we're continuing on to page 3 of this prereq review, and we're doing more of proving if we can, or showing if we can prove that triangles are congruent. So for number 29, notice how we only have two pieces of information. We have an angle and a side. We don't have any shared sides with these two triangles. We don't have any vertical angles. For this one, this will be not possible. Okay. Number 30, we have another vertical angle problem. I can recognize this because it forms like an X shape, or it almost looks like a bow tie. Okay. These are vertical angles, so they are congruent. And if we look, we have to remember what the different forms that we can use to prove triangles congruent. Well, we have an angle here, we have another angle here, and we have a side. Notice how I did not go around counterclockwise. I didn't say angle, then side, then angle. The angles have to be one after another. They have to be consecutive. So angle, angle, then side. And if the side was consecutive, then I could go that route. But since this side is not consecutive to this angle, I have to go angle, then the consecutive angle, then the consecutive side. My favorite, AAS, angle, angle, side, or Amos Alonzo Stagg. So we know that we will be using AAS for this one. Okay, again, AAS. And then in the proper order, WXY. So I go from the single swoop to the side. This one would be the single swoop from A to Z to Y. The next one is a nice one. Notice how we have an angle here, an angle there. So it's going to be something with two angles. And we have this side. I always mark when they have a shared side, these two triangles, I always mark it as an X, just so I can remember it's a shared side that they both share. This is a side. So by ASA, we can say that STV is congruent to UVT. Be careful on the order though, because notice how STV went from a single swoop to a double. Then I have to go U to a single swoop to a double, UVT. Number 32, another shared side problem. Notice how we have a side, then an angle, then a side. So by SAS, we can prove these two triangles congruent. MJK would be congruent then to KLM. Number 33, we have a side and another side. These two appear to be congruent, but since we don't have another piece, we don't have a right angle congruent, we don't have any other sides congruent, this one is not possible. And then 34, again, another shared side. So we have side, angle, side, consecutive in a row, so SAS. And ABD, A, then B, then D, would go with C, B, D. It's asking us what is CPCTC. Okay, it's an acronym for a property that we will be using in proof writing. This means that corresponding parts of congruent triangles are congruent. So basically, it would be pretty much used at the end of a proof. If we know that two triangles are congruent, then we can list all the other corresponding parts that are congruent, like other sides, other angles, and so on. How do I use CPCTC? What you would want to do is first prove the triangles are congruent, and then, like it says, CPCTC will be your last step. So using the triangles, the two congruent triangles, to show that the corresponding pieces are also congruent. All right, 36 tells us to label the corresponding parts of triangle RST, and triangle ABC. they want us to label here and then maybe label on the triangles. So again, angle R goes with angle A. S, I'm going to use 2, goes with angle B. And then angle T, I'll use 3, will go with angle C. Then we can label the sides that are congruent. The side RS will be congruent to AB. ST will go with BC. And then lastly, RT, I'll use 3 little ticks. So RT will go with AC. So now angle C, we know goes with angle T. Segment AC would go with RT. Angle R with angle A. And ST would go with BC. Some vocabulary that you need to be aware of: complementary angles. Those would be angles that add or have a sum of 90 degrees, so angles that add to 90 degrees. Supplementary would be angles that add to 180 degrees. The way that I remember is in the alphabet, the letter C comes before the letter S. In the number system, the number 90 comes before the number 180. Okay. And the last one of this page, it says if the measure of angle P is 28 degrees and angle R and angle P are supplementary, meaning they add up to 180, angle T and angle P are complementary, add up to 90, and angle Z and angle T are complementary, again, add up to 90. Find each of these measures. Well, if we know that R and P are supplementary, then we know that the measure of angle R is equal to 180 minus 28, because we know that these two, R and P, would add up to 180. If we know one of them, then we would know the other. When you subtract 28 from 180, you get 152 degrees. So measure of angle R is 152 degrees. Let's find the measure of angle T. Well, T and P are complementary. We know that P is 28, so 90 minus 28 is going to give us 62 degrees. So measure of angle T is 62 degrees. And then Z, it says Z and T are complementary. Okay, well, we know that T is 62. So to find the measure of angle Z, we would take 90 minus 62, and you might already know that that's going to be 28, since we already knew that angle P was also 28.